Hi everyone, welcome to my Urban Stormwater Infrastructure Data Collection Training video. In case you don't know, my name is Emily Henry, and I'm a Big Sky Watershed Corps member serving with the City of Kalispell and the Flathead Basin Commission. If you're tuning in because you're interested in participating in the data collection campaign, let me start off by saying thank you. This is a really exciting campaign for me, and it wouldn't be possible without your help, so thank you for considering being a part of it. And if you're tuning in to get a better idea of what this campaign entails, I hope this video helps to clarify any questions you may have about it. I decided to make this video to help you better understand why the data you're going to collect is important and how to use the materials that will be provided to you to actually do it. I'm going to start off with just a brief overview of stormwater itself and stormwater management, because there is a lot of jargon in the stormwater world, so I'm hoping to just get us on the same page with all of that terminology. Then I'll talk about the ultimate goal of the project and why it's important, before jumping into exactly what data you're going to collect, the procedure you should follow to get it, and how to document it in a way that will make my life easier later on. Let's get started with an overview of stormwater. So when there is any kind of precipitation on a landscape, that water has essentially two options of where it can go. If it lands on a permeable surface, it can soak into the ground and become part of the groundwater system. Examples of permeable surfaces include forested areas, residential rain gardens, permeable pavement, and gravel. If it lands on an impermeable surface, it runs over the landscape and becomes stormwater. Examples of impermeable surfaces include parking lots and roadways, rooftops of buildings, and soil that has been compacted by construction. So, in the most basic sense, stormwater is just any water that flows over a landscape. Super simple. So when we think about urban and residential areas, there are tons of these impermeable surfaces. So it's not super surprising that these areas produce a lot of stormwater. There aren't a lot of places where this water can soak into the ground, so it doesn't. Instead, it flows off of roofs, onto roadways, and into what we call catch basins. The term catch basin just refers to an engineered drainage structure that facilitates the movement of stormwater from roadways or parking lots to a local water body. Here are some examples of what they may look like. You've definitely seen these within roadways or along curbsides before. They're really everywhere. So as I kind of said, the purpose of catch basins is twofold. One, they serve as an inlet for stormwater, allowing that stormwater to get off the roadway and enter into the system of underground pipes that moves that stormwater to a local water body. And two, they ideally catch any debris that the stormwater was carrying with it, like leaves or garbage, hence the term catch basin. So from the street, these catch basins look like they're just holes in the pavement, but it's important to realize that they all have pipes attached to them. So inside each catch basin, beneath the grate and down in the hole, there is minimally one outflow pipe, or a pipe that is carrying away any stormwater that flows into that catch basin. There can also be inflow pipes, or pipes that are carrying stormwater that flowed into a different catch basin further up in the system. There can also be a number of inflow and outflow pipes in more complicated systems, but for the areas we're looking at, there will probably only be at most 2 inflow pipes and 2 outflow pipes. Differentiating between these inflow and outflow pipes can be a little complicated, and I'll talk more about that later on when I describe the methodology. But for now, just know that there are these things called catch basins that allow stormwater to enter into the underground stormwater system beneath roadways through this system of pipes. Once stormwater passes through these catch basins and enters into this underground pipe system, it starts making its way toward an outfall. Outfalls are locations where these pipes end, and the stormwater that was being transported through these pipes enters into a local water body. Outfalls are typically located along the banks of rivers and streams and lakes where urban areas meet the water. Underneath bridges, where roadways cut across streams or rivers, are also very common outfall locations. Here are some examples of what outfalls may look like. Knowing the locations of outfalls becomes super important for water quality monitoring efforts because these are the places where potentially polluted stormwater is flowing into bodies of water. So when we collect stormwater samples, a lot of times we're getting them at outfalls. And finally, I want to take a second to talk about storm manholes as well. Manholes are essentially locations where people can see into one particular pipe within the underground stormwater system. So basically there's one pipe with its top removed running through the manhole. So if you were to remove the manhole cover, you could potentially see stormwater flowing through an open-topped pipe. They're really similar to catch basins in that there is an inflow and outflow pipe in a manhole. But they're different from catch basins in that they're not points of entry for stormwater to enter into the system, but are rather just areas where we can get a glimpse into what stormwater that's already in the system is doing, the rate at which it's flowing, maybe collecting samples, that kind of thing. There are manholes for stormwater and for sanitary sewer, and theoretically, the manhole cover tells you what system this particular manhole is connected to. Here are a couple graphics that show how catch basins, manholes, and outfalls are all connected along stormwater's journey from roadways into local water bodies. If the connection between these three types of infrastructure is still unclear to you, I encourage you to pause here for a moment and really take a look at these schematics. So now that we know what stormwater catch basins, manholes, and outfalls are, let's transition into the overall goals of this project. I mentioned it briefly during my discussion of outfalls, but this matters because stormwater can carry pollutants from the landscape into water bodies. These pollutants are numerous, and they all have different effects on water bodies, but I'll just briefly mention a few. Nutrients like nitrates and phosphates can come from agricultural activities, residential overuse of pesticides and herbicides, and even pet waste that's left on lawns. If they accumulate in water, these nutrients can cause dead zones where algae overgrowth on the surface causes aquatic organisms deeper in the water column to die. Oil and grease are another group of pollutants that we are concerned about. This oil and grease can come from leaky cars or from gas stations, and once it enters water bodies, it can dramatically decrease the insulating ability of aquatic mammals' fur and aquatic birds' feathers and cause them to die of hypothermia. There are lots of other potential pollutants I could talk about, but I think you get the idea. And these pollutants are just hanging out on our lawns and roadways, waiting to get picked up by stormwater as it makes its way into our water bodies. Another thing I want to stress here is that land use area makes a difference in what types and how many pollutants are entering into a water body at one particular outfall. And we can't know these land use characteristics if we don't know what the drainage areas of a particular outfall are. For example, here's a snapshot of Kalispell's stormwater infrastructure map. The city of Kalispell mapped the locations of its catch basins, outfalls, stormwater manholes, and other types of infrastructure in order to determine what areas of land were contributing drainage to which outfalls. In this case, if we zoom into one particular area, you can see one drainage basin, which means that all of the area in purple drains to these catch basins, symbolized by the squares, flows through the pipes and under manholes, and discharges at this one outfall over on the far left. Because we know this, we can guess what kinds of pollutants may be entering our waterways at this one outfall. As you can see, this is a residential area, so we wouldn't expect to see high concentrations of heavy metals or any other pollutants associated with industrial areas. We also wouldn't expect to see tons of nutrients, which are typical of agricultural areas. We might see some from over-fertilizing lawns and pet waste that wasn't picked up, but not to the same degree as we would see them if this entire area was cropland. This is really important to know, because then we can start to prioritize outfalls to monitor based on what kinds of negative effects we're seeing in our water bodies. For example, Flathead Lake has experienced problems with eutrophication and dead zones caused by excess nutrients in the past, and scientists were trying to figure out exactly where these nutrients were coming from. They may have looked at this outfall, have seen that it was a residential drainage area, and maybe ranked this outfall as a medium to low prioritization for monitoring, expecting to find some nutrients from lawn chemicals, but not too many, since it's a relatively small, non-agricultural drainage area. Then they could have focused their efforts on other outfalls that may drain a larger, more agricultural area, which would likely be one of the main culprits in this particular pollution scenario. And that brings us to the overall goals of this project. The primary goal, which is the direct goal of your individual contributions, is to identify where catch basins, outfalls, and manholes in urban areas are located and figure out how they're all connected to one another. Then we can take a step back and assess how worried about a particular outfall we should be, which is the secondary goal or the indirect goal of your individual efforts. Because of your work, we'll be closer to understanding where pollutants in Flathead Lake are coming from and can then help to mitigate them. And that's the overarching goal motivating the project, why we care about stormwater in the first place. Once we know more about this stormwater infrastructure, we can ask questions about the sizes and land use classifications of sub-drainage basins and start to think about what implications that has on potential pollutant loads. But we need the stormwater infrastructure data to begin to answer these questions, and that's why your help is so important. So, now that you know the terminology and have a good idea of why we're doing what we're doing, I'll get into the bulk of what this video is about, which is an explanation of how to collect stormwater infrastructure data. The methodology I'm closely following was described in this story map created by Joshua Rotbert and Cameron McGrath in the town of Clarkstown, New York. If you want more information about stormwater infrastructure or why our knowledge of infrastructure matters, I encourage you to check this presentation out. To get us started, I divided the urban area of interest into a number of sections of manageable size. Here you can see an example map of Polson and its 13 sections. Each pair of volunteers will be assigned certain sections for which they are responsible for collecting data. In this case, each pair has been assigned 2 sections. And essentially, you and your field partner will pick up the provided materials and bring them with you out in the field, where you will walk up and down each of the streets in your assigned section, searching for manholes, catch basins, and outfalls if your assigned section is along the lake shore. Primarily, the focus is identifying infrastructure along roadways, but if you have time, parking lots of businesses within your section may also have infrastructure you could document as well. But that's really all this process entails, just kind of wandering along the streets until you find a catch basin, a manhole, or an outfall. Each partnership will be provided with the following materials for collecting data: a retractable tape measure, a handheld compass, a flashlight, 2 reflective vests to wear when you're out collecting data, writing utensils, a clipboard with some important references, and a folder full of maps and blank data sheets. I'm going to take some time now to break down the purpose of all of these materials. First, on the clipboard are some really important references. You'll find the map of Polson with all of the sections labeled, which you can use to help orient yourself if you forget the exact location of your sections. You'll also find something I've termed the data collection cheat sheet, which has the definitions of some of the terms on the catch basin data sheets and images of some things that may help you along the way. Specifically, the differences between curb inlets and area inlets, and all the different pipe materials are shown on this cheat sheet. Reference this whenever you're not sure about what something on the catch basin data sheet means. Also on the clipboard, you'll find a slip of paper with responses to questions that people may ask you while you're out collecting data. I've never been out doing work in an urban area when people haven't talked to me, so these are just some responses to common questions I get asked. To this slip, I've also attached a couple copies of my business card. If you encounter anyone who wants to know more information about the project, or who is hostile in any way, which shouldn't happen, but you never know, just give them my card and tell them to contact me directly. In the folder, you'll find the maps and data collection sheets for each of the sections your pair is responsible for. First, you'll fill out the info cards on the outside of each of the pockets. That's just to help me keep track of which folder has which data. Within each pocket are 3 maps. The first 2, labeled Streets A and Streets B, are zoomed-in maps of your section on which you will mark the locations of each catch basin, manhole, or outfall that you find. The only difference between the 2 maps is that Streets A is underlain by a blank background and Streets B has the satellite imagery behind it. You and your partner can annotate either or both of these maps. I have no preference, so long as each feature is marked on at least one of them. I thought it might be easier to annotate the blank map since it's less busy, but the satellite map may be useful for figuring out exactly where you are, since you can use nearby buildings as reference. I'll talk more about annotating later on, but just know that these are the 2 maps you can use to do that. I also just want to point out that on these 2 maps, any streets for which you are not responsible for getting data have been blacked out to avoid any kind of confusion. The third map in the pocket is a map of flow direction, which is just the direction water on the surface of the earth will flow at that particular location. The red arrows indicate the magnitude and direction of flow, meaning that larger arrows are representing a steeper slope. This map may be useful for determining which pipes in a catch basin are inflow and which are outflow pipes. In addition to the maps, you'll find a set of blank data sheets for catch basins, a blank data table for manholes, and a blank data table for outfalls. These data sheets and tables are the most important and most complicated part of this whole process, so I'm going to spend some time talking specifically about how to fill in the catch basin data sheet. So imagine you and your partner are wandering the streets, looking for catch basins, and you find one. First thing you'll do is make sure it's in a safe area of the road. This is an important step. If it's in the middle of a busy intersection, you can make note of it on the map, but please do not investigate any further. I value your lives very much, so please do not risk them. Okay, so you've done that, and have determined that the catch basin is in a safe, accessible spot. Awesome. One partner will be the data collector, and the other will be the data recorder. I'll talk a little bit about what each of your individual responsibilities are here coming up. First, the data recorder will whip out a data sheet and fill in the catch basin number. which is essentially arbitrary. I just number them in the order that you come across them. Then you'll take out one of the maps and the red Sharpie, which not coincidentally is labeled catch basin, and make a dot at the location and label it with the catch basin number. Marking both the location and the number will be really necessary for me when I go to analyze the data. Then you'll mark whether it's an area inlet or a curb inlet. If you forget what either of these terms means, refer to the handy-dandy cheat sheet on the clipboard. You'll note the condition, whether the grate looks like it's in good shape or not. Some of them can be broken, so it'll be pretty obvious if it's in bad shape. You'll also make any additional notes on the notes line, which could be anything out of the ordinary that you notice about this catch basin. Maybe there's an excessive amount of debris on top, or a weird smell coming from inside. Let me know about it. Then you'll just copy down whatever numbers the data collector throws your way to fill in the rest of the sheet. So, while the data recorder is doing all of that stuff, the data collector can be really investigating the catch basin, getting really close and personal, trying to look down and using the flashlight if necessary to see what the pipes look like. You will probably have to get your face really close to the ground to do this. You'll use the tape measure to measure the size of the grate, either a diameter measurement if it's a circular basin, or a length by width measurement if it's rectangular. Then you'll measure catch basin depth, which is just the depth from the surface of the grate until the very bottom of the catch basin. Sometimes you'll find a lot of debris in the bottom of these basins, which may prevent you from getting the tape measure all the way to the bottom. And if that's the case, just make a note of it. You'll then figure out where the pipes are and whether they're inflow or outflow pipes. If there's only one pipe, it must be an outflow. But if there are multiple, this process can be a little complicated. Usually you can tell the direction water would flow just by looking at the gradient of the street. But if that's really difficult, you can use the flow direction map to help you. For each of the pipes, you'll then measure the depth, which I have defined as the depth from the surface of the grate to the bottom of the pipe, and estimate the diameter of the pipe. It will probably be really difficult to actually read the tape measure once it's in the catch basin, so a solid estimate of pipe diameter will do. You'll then identify the pipe material, again using the cheat sheet to help you if you forget which is which, and the orientation of flow of each of the pipes using the compass. Data recorder, you'll want to fill in these numbers on the data sheet as the data collector reads off the measurements. Then you'll want to draw arrows for each of the inflow and outflow pipes in the little box at the top of the data collection sheet. Here's an example of what a completed data sheet should look like. Double check that you have the location and number marked in red on the map, and you're good to move on. And you'll just repeat this process for all of the catch basins within your section. In addition to catch basins, you'll want to look for stormwater manholes and outfalls as well. Both of these have a much simpler documentation procedure than the catch basins. All you have to do is fill in a row of the manhole or outfall table for each one you see. On the manhole data table, you'll just circle a word or phrase that most closely matches what the manhole cover reads, and you'll record anything noteworthy about its condition. Any manhole that says sanitary sewer on the cover you can ignore. For simplicity, we're going to assume that all of the covers are accurate. You'll want to use the blue Sharpie to mark the location and number of each manhole according to the manhole number listed in the table. If the section your pair was assigned lies along the lake shore, or if there is a stream or river cutting through it, you'll also want to look for outfalls. This process is a little less straightforward than looking for catch basins or manholes because outfalls don't lie along roadways. To find outfalls, you'll just want to take a brief walk along the shoreline or riverbanks, assuming, of course, that this is not private property and you feel safe to do so. You'll look for the ends of pipes, and you'll just want to record an estimate of the diameter of the pipe in the table if you do find any. And as usual, record the location and number of the outfall according to the outfall number listed in the table using the black Sharpie. And again, you can skip this step if your section does not lie along the lake shore or have any rivers or streams cutting through it. And just want to stress again that if it is obvious that in order to search for outfalls, you would need to trespass on private property, please don't do this. This will be a judgment call, so if you feel uncomfortable at any time, listen to your gut and don't worry about the data. Okay, that was a lot of information, so I'm just going to take a second here to recap. You and your partner are responsible for locating and characterizing catch basins, stormwater manholes, and outfalls within your assigned sections. For catch basins, you'll need to use the tape measure, flashlight, and compass to collect measurements and record those measurements on a blank catch basin data sheet. Make sure to mark the location and number on the map in red. For manholes, only mark those that say storm, storm sewer, or nothing on the cover. Fill out a row on the manhole data collection sheet and mark the location and number on the map in blue. For outfalls, make an estimate of pipe diameter on the outfall data table and mark the location and number on the map in black. If your section is not along the lakeshore and doesn't have any streams or rivers cutting through it, again, you don't have to look for outfalls. I want to stress again that safety absolutely comes first. When you're out in the field, please wear the reflective safety vest and don't stay anywhere you feel uncomfortable just to get data. Make a note of where those places were and leave. This isn't an extremely dangerous job, although it may seem that way given the way I'm talking about it, but I just really want you guys to be safe and take that really seriously. And lastly, I want to close with a reminder of just how important this is. It may look like a whole lot of work for something that doesn't seem to matter, but the data you collect will help us to better understand what pollutants may be entering into Flathead Lake or where pollutants that are already in the lake may have come from. This data will directly inform our future water quality monitoring efforts along Flathead Lake, which is incredibly important for keeping this amazing natural resource clean for generations to come. Thank you all so much for your willingness to help in this endeavor. I hope this video gave you some clarity on why and how we do what we do, and if you have any questions about any of the information covered here or anything I may have missed, don't hesitate to email me at ehenry@kalispell.com or call me at 406-249-2241. And thank you so much for watching.